What we're learning about today, guys, is how we can use trigonometric identities to show that certain trig equations are true, or the left-hand side is equal to the right-hand side. Now, this sort of thing is not the sort of thing that's easily taught, because I could go ahead and say, all right, boys, remember these trig identities here. And then I want you to remember the next lot of trig identities. And then I want you to remember the third lot, and then I want you to remember the fourth lot, but it's not really manageable. So we're lucky because in SACE, we always give you one of these formula sheets. If you look on the top left of the formula sheet, you're going to notice the trig identity that looks similar to this. This one, and I'll get you to annotate on our sheet as we're going. This is called the Pythagorean identity. You've seen it before, haven't you? Remember we proved it in the geometry topic?
Yeah.
No, in the trig topic from stage 1. So Pythagorean identity, it just simply states that sine squared plus cosine squared is always equal to 1, and then you can just rearrange it. So that's Pythagorean identity. The next one we look at are the reciprocal. The reciprocal trig functions are the 1 over sine, 1 over tan, 1 over cosine. Now these ones are a little bit tricky to see because they're just all different new functions, or the 3 new functions to look at. The way in which I remember these is I look at the last letter of them and it aligns to the first letter. Secant is 1 over cosine. Cotangent is 1 over tangent. That'll do. And then there's this final one, cosecant. We often spell it as CSC, depending on the reference book you're using. But this is the odd one out. The long one is 1 over sine. That's how I remember it. Are we cool? We've seen that before? All right, now what we're going to do is, using the trig identity and possibly the reciprocal rules, is we are going to show that 1 plus cotangent squared all over cotangent theta times cosecant theta is equal to just secant theta. Now when we're doing these, what we typically try to do is we go from high complexity to low complexity. You can prove that the right hand side is equal to the left, or you could show that the left hand side is equal to the right hand side. Either way is fine, but the way I typically recommend you do it is you go from high complexity down to low complexity. It's always easier to go that way than the other way, I find. So starting off, which one looks like the most complex, please, Isaac?
The left-hand side.
Attaboy. We're on the same wavelength.
Yeah.
You've been very good this lesson.
Whoa. Isaac, you might get your first Santa visit.
All right, so there we go. This is our starting off. Now, next step, what we need to think is, well, we've got a we've got a fraction, numerator, denominator, but actually we've got something that I was talking about in the last example we looked at it. Whereas if we use these rules over here, we're going to find our fraction is not so nice, because if I expand this out, tangent or cotangent is going to turn into 1 over tangent, which is the same as cosine theta over sine theta. And I need more space, I'm afraid.
So does it matter whether you write cosec or CSC?
No, it doesn't matter.
Okay.
It's whichever one you personally preference.
Yeah.
We agree? Okay, and then this one over here, this is 1 plus, and this is going to be cosine or reciprocal, cosine squared over sine squared theta. All right, so have a look. We've got something not so nice. Since we've got something not so nice, what should our first step, do you reckon, be, Rowan? To change this into...
You could cancel out the cos theta over sine theta. That one from the bottom and then...
Can we cancel the bottom one out?
I don't know.
Because...
We cancel out the squares on the top.
We're still in the step where we've got multiple fractions up here. So before we start ripping it all apart, let's make it so we've got this in its simplest state up top.
Sine squared theta over sine squared theta.
Yeah, and then work our way down. So this is sine squared theta over sine squared theta. And this is really great because it's our first simplification that we're going to do. So I turn this one into sine squared theta over sine squared theta. Then it's cosine theta, or cosine squared theta over sine squared theta. Sound cool? Now downstairs, this is going to be sine squared theta, and this is just cos theta. Now, first thing you're going to notice, these are of the same denominator, so let's put them together. Then, before we do anything, let's have a look at what trig rules we have, or trig identities. Is there anything that can simplify that sine squared theta plus cosine squared theta?
Equal 1.
So up here, it just becomes 1. That's our first simplification so far. So we're going to get 1 over sine squared theta. And then downstairs, we've still got this guy. Okay, next step. We've got three fractions. One upstairs, one downstairs, and one that's holding those upstairs and downstairs together. So here, here, and all together here. Let's split it apart and write it as a single fraction. To do this, we simply get the numerator and write it out front. Times, then grab the denominator, flip it upside down, so suplex it, and then do it as a times. Sorry, this should be a squared here. Okay. Second last step. What do we have and what can we cancel? Brad?
The sine squared.
Bingo. Sine squareds are gone, so it becomes 1 over cos theta. And then final identity. How do we bring it home, Mad Dog?
Use the reciprocal trig function.
Yeah, reciprocal trig function. Secant theta is equal to 1 over cosine theta. So this turns into secant theta. And therefore, our left-hand side is that. So our left-hand side is equal to our right-hand side. All cool? So that's all well and good to see your teacher do that, but stop and think, what did your teacher do to know how to tackle this problem to get to the answer? First step, which side do we choose and why? Lenny?
We choose the harder side.
Yeah, we choose the side of higher complexity. Why? Because it's always simpler to go from high complexity to low complexity. Sometimes no, but in most cases yes. Next step. We had our fraction. What did we do to this fraction, Rowan? Here to here. What step did we think to do?
Made them have common denominators.
Yeah, common denominators. So that was here to here. But we saw that there were reciprocal functions. We're not used to them yet. So we turned them back into our vanilla functions. Sine, cosine, tangent. And in some cases, we just turn tangent into sine and cosine. This allows us to see, I guess, straightforward relationships of cancelling out, so factors and cancelling. Moving down, we made the fractions fractions, and then we used our first identity. When we see an identity, we go for it. At this point in time, when we see it, we just go for it. That simplifies it down. Then it's just partial fractions from there. Any questions? Is this something we can do? All right, cool.